but I'm going to go ahead and present one more problem just because why not? Math is fun. So let's take a look at target number 8, which reads as follows. Let A and B be relatively prime positive whole numbers. If exactly 2 of the numbers A minus 3B, 3A minus 5B, and 5A minus 7B are positive, and exactly 1 of the numbers A divided by 3B, 3A divided by 5B, and 5A divided by 7B is a whole number, then what is the sum of all possible values for A plus B? So let's first take our first set of conditions, right, with our subtraction conditions, and just write out some inequalities for those. We have A minus 3B is greater than 0, 3A minus 5B is greater than 0, and 5A minus 7B is greater than 0. Now, what we can do is we can move the B terms to the other side and divide them out. What I mean by that, we have A is greater than 3B, so A over B is greater than 3. We can do that for other similar terms, right? And that would give us A over B is greater than 5/3. And finally, A over B is greater than 7/5. Now, we need to know which 2 of these are true, right? And what we can notice is that 7/5 is less than 5/3 is less than 3. And what that means is that A over B has to be greater than 7/5 and 5/3, but not 3. Why is that the case? Because if A over B were also greater than 3, then all 3 of these would be true, and that violates the conditions given in our problem, right? So this means that A over B, right, is less than 3, but is then greater than 5/3, which is our next largest fraction here. Now we have to see what our other condition is. A over 3B, which is equal to 1/3 A over B. 3A divided by 5B, which is 3/5 times A over B. And 5A divided by 7B, which is 5/7 times A over B. Only one of these is a whole number. How do we figure out what those can be? Well, we know what the bounds of A over B are, and since 1/3, 3/5, and 5/7 are all positive numbers, we can just multiply them through this equation up here to get our results for the bounds of those 2. Then, if we multiply, say, 1/3 by this entire equation, then we get that, oops, I missed an equal sign here. Remember that A over B can be equal to 3 because it just can't be greater than 3. We multiply through everything by 1/3, 3/5, and 5/7 to get 5/9 is less than 1/3 A over B is less than or equal to 1. We multiply by 3/5 to get 1 is less than A over B is less than or equal to 9/5. And then finally, we multiply everything through this last one, 5/7 A over B, to get our last condition as 25/21 is less than A over B is less than or equal to 15/7. Now, what solutions do we have for this, right? Well, we know that these have to be whole numbers, right? These numbers in the middle, only one of them can be a whole number. So how can that be the case? Well, in this top one, this means that 1/3 A over B can equal 1. There's a solution, right? There's no whole number solution greater than 1, but less than or equal to 9/5, so we have nothing there. And then 25/21 and 15/7, between those would be 2. So that means that 5/7 A over B would equal 2. These are the only 2 solutions that we have. Now, using that, we then rearrange to get A equals 3B over here. And down here, we have 5A equals 14B. Now, how do we figure out the values of A and B, right? There's infinite many solutions to A equals 3B and 5A equals 14B. Well, we know they're whole numbers, so that kind of helps us. But the most important part is the relatively prime whole numbers. Relatively prime means that the only common factor they have is 1. right? Which means that A has to equal 3 and B equals 1 here, and A equals 14 and B equals 5 here. Now, the reason for that is if A and B were larger, then they would have other common factors, right? So if A equals 6 and B equals 2, then they have a common factor of 2, which means they're no longer relatively prime. Now we calculate A plus B for each of these two scenarios. A plus B equals 4 in our first case. A plus B equals 19 in our second case. And we are asked to find the sum of all possible values of A plus B, which gives us 4 plus 19, which is 23. So our final answer for target 8 is 23.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.